Here's the Central Valley. In fact, geologists call it the Great Valley. And what it is, the approximate thickness is over 30,000 feet of sediment in there. You could put Mount Everest in our California Central Valley and it would be buried by sediment. There's so much sediment there. And where did all this come from? Well, remember the Sierra Nevada used to have big volcanoes. Today, when you go to the Sierra Nevada, you mostly just see the granite. But in the past, remember these granitic rocks were once very deep, and they were overlain by lots of other rocks, including big stratovolcanoes like Mount Shasta type volcanoes. They're all gone. They've been eroded, and many of those are now sitting in, well, their products, their eroded product is now sitting as layers in the Central Valley. So what we got here, yes, we got over 13,000 feet of sediment. So the source is the Sierra and some parts of the coast ranges. But remember, the Central Valley is California's breadbasket. It's an agricultural region. It serves 40% of the nation's food, right? So it's a major agricultural region. Also, remember, the Central Valley or the Great Valley has a northern Sacramento Valley for the Sacramento River and a southern San Joaquin Valley. And the northern Sacramento Valley part of it, the smallest mountain range on, well, at least in California, are the Sutter Buttes, which are a series of lava domes, little volcanoes, related possibly to the southern extension of the Cascade Range, but they're probably more likely related to the northern development of the San Andreas Transform. And later on, when we talk about the coast ranges, you'll see how this changed through time. In fact, here are the coast ranges, right? So the coast ranges, northwest training ranges by parallel river valleys, is dominated by the San Andreas Transform system. There are many examples of ocean floor rocks that have been attached or accreted to California. Some of the important ranges we find some of these pillow lavas are in the Santa Cruz Mountains, the Diablo Range, the Gabilan Range, Santa Lucia Range down in Big Sur, the Temblor Range, which is down by San Luis Obispo. Temblor means earthquake in Spanish, so again, it tells you about this active nature of the San Andreas Fault. And so here's the trace of the San Andreas Fault, right? Remember, the largest historical earthquake in California was the 1906 earthquake in San Francisco. This Carrizo Plain, which this region is near, is a region where the San Andreas Fault is clearly you can clearly observe it, and you can get a good idea of the sense of motion on the San Andreas Fault. And in fact, we'll look at this Wallace Creek later on. And then where does the San Andreas Fault cross Highway 17? Over by the south end of Lexington Reservoir. In fact, this is Wallace Creek right here. So here's a trace of the San Andreas Fault. And in this case, we're looking toward the west here. So north is on the right here, south is down on the left. And so this creek, Wallace Creek, flows, hits a fault, and it makes a parallel, follows a parallel coast to the fault, and then it goes off this way. So this clearly shows offset, because this creek should go straight down the hill here. But it's been offset, and now it moves this way. So here's a good example of a right lateral strike-slip fault. Here's another example. I've taken some students here. This is a winery down near Hollister. It's called the De Rosa Winery now. It used to be called the Cienega Winery. But here's a culvert that was built in the 1960s. You can see it's clearly offset again to the right, right? So again, showing, so the San Andreas Fault is going right through here, and it's again showing this right lateral offset. Another interesting piece of the puzzle here in the coast ranges of California are these rocks that are part of the selenium block. And they're exotic to coastal California. They shouldn't be here. In fact, in other words, what happens is they formed elsewhere and were tectonically transported. So, and these rocks are mostly the rocks that are to the west of the San Andreas Fault. So actually, like the UC Santa Cruz campus is composed of this exotic terrain called the selenium block. In fact, I've taken students, this is actually at UC Santa Cruz, there are caves up there, and they're marble caves. Well, there should be no marble in the coast ranges, yet here it is. Again, formed elsewhere, has been tectonically transported. But the marble caves, we can kind of go in there, and there's some back rooms you can in there, and there's some crawl spaces there. It's a pretty fun place to visit. Now the next two areas, Cascades and Modoc, I'm going to do these together because they both share a similar history. They both have young volcanoes and young volcanic rocks. So general rock type and age, they're volcanic rocks and they're young. And but one thing is the Modoc Plateau is very flat. But the Cascades, those are high volcanoes. Think of Mount Shasta, right? So why are the landforms different? Well, it depends on the chemistry of the product of the volcanic rocks. The Cascades, like Shasta, is composed primarily of a rock called andesite. In fact, this comes from the Andes Mountains. So the volcanoes in the Andes are also erupting andesite. And so that's very typical of these stratovolcanoes. Whereas basalt, that's typical of a more fluid or effusive rock that doesn't tend to pile up. It tends to flow and make flat layers, or shield volcanoes like Hawaiian volcanoes, right? So generally flat. So the difference is the type of lava and the chemistry of the lava. And in terms of geography, remember the Cascades, they go up into Washington State, Oregon. You know, they think of Mount Rainier, Mount St. Helens. Those are all part of the Cascades. And the Modoc Plateau were really kind of the southern extent of the Columbia River Plateau, which is eastern Oregon, Washington State, and over into Idaho. And then another question I always have is, what tectonic plate is subducting under California? And it's this little Gordo plate right here. And so if you look at, there's a mid-oceanic ridge off of northern California called the Gordo Ridge. And then the plate that's being subducted is the Gordo plate. And that's what's generating magmas to form our Cascades here in California, like Mount Shasta. Now, Lassen Peak, there's another one there. And for the Modoc, remember, it's very flat because there's primarily effusive rock that tends to flow very far and makes these successive lava flows to flatten out the topography. In fact, plateau, it's an elevated plain, right? A flat region. And then there's a lot of these cinder cones, which are basaltic lava. And here's another example. In fact, here's a good contrast. So we have the big Medicine Lake volcano in the Modoc Plateau region. It's relatively flat. It's basalt lava. Then we have the peaky Mount Shasta, which is the adjacent province of the Cascades, and that's our andesite. So basalt for this Medicine Lake volcano, a shield volcano, and then andesite for the Cascades. And finally, the last region here are the Klamath. They're just like the Sierra Nevada. They have the same gold deposits, same granitic rocks. Here, these castle clogs are all granite, same age. There are also a lot of oceanic rocks, a lot of fossils. In fact, I have a couple of questions about later on about the types of fossils and where these rocks may have been in the past, right? So anyways, we'll stop here for now.